All right, today we're going to peek under the hood of one of the most important machines in our daily lives, the gas furnace. It's that invisible workhorse that keeps so many of us warm. So let's pull back the curtain and see exactly how it turns simple fuel into cozy comfort. You know the drill, right? You nudge the thermostat up, you hear a little click, and then bam, warm air starts flowing out of the vents. It kind of feels like magic, but it's actually a pretty fascinating and very controlled process. So what is going on in there? So why gas? Out of all the options, why do so many homes run on natural gas? Well, it really boils down to this simple fact. From our source material, it's just the easiest fuel to use for this particular job. And that convenience is a really big deal. At its heart, the popularity of gas comes down to sheer convenience. I mean, think about it. The ability to just pipe fuel directly into a building on demand, that was a total game changer. And it's why it became the go-to choice for millions. And what's really cool is how well that convenience scales up. The same basic principle that heats your house can also keep a massive commercial building warm or even power huge industrial plants. That kind of versatility is a huge reason for its success. Okay, so we've covered the why of using gas. Now let's get into the how. To do that, we're going to use a simple schematic as our roadmap to break down the entire process step by simple step. And here it is, our map. Now, I know it might look a little technical at first, but trust me, it's a really simple and logical journey. We're just going to follow the path from fuel to heat, starting right at the beginning. So now we're getting to the real heart of the machine. Combustion is just a fancy word for burning, right? But inside a furnace, it's an incredibly precise and controlled chemical reaction. So let's follow the two key ingredients on their journey. Okay, check this out. Step 1. Over on the left, you can see a blower is pulling in air from outside. At the same exact time, the gas fuel is being piped in. They both get pushed into this mixer, and its whole job is to whip them up into the perfect, most combustible blend possible. From that mixer, the ideal fuel-air blend moves right into the combustion chamber. This is where the magic, or, the science, really happens. An igniter gives it a spark, and poof! A controlled burn starts up, releasing all that chemical energy stored in the gas in the form of heat. And that brings us to the final and maybe most clever part of the process. All those super hot gases from the fire, they flow through a series of tubes called the heat exchanger. Now here's the key. The air from inside your house is blown across the outside of these hot tubes, soaking up all that warmth. That toasty air gets sent through your ducts, while the leftover combustion fumes are safely vented outside as exhaust. The two never actually mix. It's a brilliant, safe design. So it seems pretty straightforward, doesn't it? Mix, burn, exchange heat. But honestly, doing this safely, reliably, and super efficiently, well, that's actually a pretty sophisticated bit of engineering. There's way more to it than just lighting a fire. Which brings us right to the soul of the furnace, the burner. You see, its design isn't just about making a flame. It's about achieving 4 really important, totally non-negotiable goals. Think about it. A burner has to be safe, period. That's number 1. It also has to be reliable. It needs to fire up every single time you need heat. Then it has to be highly efficient, squeezing every last bit of heat out of the fuel. And finally, it's got to be clean, producing as few harmful emissions like carbon monoxide, or CO, and nitrogen oxides, NOx, as possible. Hitting all 4 of those targets, that is a serious engineering balancing act. So with all those design goals in mind, how do we actually tell if a furnace is any good? How do we measure its success? Well, it all really comes down to one crucial metric: efficiency. And we measure that using something called an energy balance. The easiest way to think about it is like a budget. Engineers measure all the energy going in with the fuel, and they compare it to the useful heat energy that actually comes out to warm your house. Any energy that's lost as hot exhaust or just leaks out of the furnace walls, that's considered waste. The higher the percentage of useful heat, the better the furnace. And that really brings us to our final thought for today. We've seen the beautiful, elegant simplicity of the gas furnace. It's a machine that's been reliably warming our homes for decades. But as our entire world pushes for better energy efficiency and a smaller environmental footprint, you just have to ask, what's next? How will this simple, fundamental machine have to evolve? What will the furnace in our homes look like 20 years from now?